To the naked eye, it's just a star, a bright point of light in the southern sky, flickering gently above the horizon. But hidden in that shimmer is something far more complex. This is Alpha Centauri, the closest star system to our own. At just over 4 light-years away, it is our nearest stellar neighbor, a tantalizing destination long imagined in science fiction and now studied in earnest by astronomers across the globe. It is a system composed not of one star, but 3, each unique, each holding the potential for something more. For decades, Alpha Centauri was simply a name, a curiosity on star charts. But today, it's becoming something else entirely, a genuine frontier. Because hidden among those stars may be planets, real, rocky worlds. Some may orbit within the habitable zone, and some may hold the one thing that would change everything: life. The Alpha Centauri system is not a single sun. It is a trio, a gravitationally bound family of stars. At its heart are Alpha Centauri A and Alpha Centauri B, 2 stars not so different from our own. They orbit one another in a slow, sweeping ellipse that takes nearly 80 years to complete. Both are relatively calm, stable, and luminous, ideal hosts, perhaps, for life-bearing worlds. Orbiting at a great distance from these twins is the third member, Proxima Centauri. It's a small, red dwarf star, faint, cold, and invisible without a telescope. But despite its dim light, Proxima has captured the greatest scientific attention, because in 2016, it revealed something extraordinary: a planet. That planet, now called Proxima b, is roughly the size of Earth, and it orbits within the habitable zone, the narrow band where liquid water could exist. It is the closest known exoplanet to Earth, and it has redefined our understanding of what lies just beyond our solar system. Detecting planets around distant stars is a feat of precision. These worlds are too small, too dim, too close to their bright parent stars to be seen directly, at least with most current instruments. Instead, astronomers rely on indirect evidence. Tiny dips in a star's brightness when a planet crosses its face, or minute wobbles caused by a planet's gravitational tug. Alpha Centauri A and B posed a particular challenge. Because they orbit so closely to each other, the signals they produce often overlap, interfering with detection methods and making it difficult to isolate signs of orbiting planets. But recent advances have changed that. With the arrival of ultra-precise spectrographs and next-generation telescopes, including the Very Large Telescope, the Gaia mission, and the James Webb Space Telescope, astronomers are finally peeling back the glare. In 2021, researchers announced evidence of a possible planet orbiting Alpha Centauri, a warm, rocky world potentially residing in the habitable zone. Though not yet confirmed, it would be a milestone, the nearest truly Earth-like planet ever detected. And it might not be alone. Proxima b is a paradox. On paper, it is everything we might hope for: an Earth-sized planet, close enough to its star for water to remain liquid, and within reach of our deepest telescopic eyes. But its star, Proxima Centauri, is no serene sun. As a red dwarf, Proxima is prone to violent flares, releasing massive bursts of X-rays and ultraviolet radiation that can strip away atmospheres and sterilize surfaces. If Proxima b ever had an atmosphere, it may have been lost. If it still retains one, it must be protected by a strong magnetic field, like Earth's, capable of fending off solar storms. There's another challenge: tidal locking. Because Proxima b orbits so close to its star, it likely shows only one face to the light, one hemisphere forever scorched by day, the other frozen in perpetual night. But between the extremes may lie a sliver of habitability, a twilight zone, a ring of moderate temperatures where winds and oceans, if they exist, could create stable conditions. We don't yet know if Proxima b is habitable, but it remains our most accessible candidate for finding life beyond Earth. And with each new observation, the picture sharpens. In most planetary systems we've studied, planets do not form in isolation. They come in families, small rocky worlds near the star, gas giants farther out, moons, asteroids, debris belts. So if Proxima Centauri has at least one planet, maybe two, it stands to reason that Alpha Centauri A and B might as well. And these twin suns are especially promising. Unlike red dwarfs, A and B are sun-like stars, more stable, more luminous, and with habitable zones that resemble our own solar system's inner region. Their radiation levels are milder, their activity less intense. In recent years, powerful infrared and thermal imaging techniques have begun to penetrate the stellar glare. What's been found is promising: signals, patterns, temperature variations, suggestive of Earth-sized exoplanets nestled close to the habitable zones. Nothing is certain yet, but the evidence grows. With upcoming missions like the Nancy Grace Roman Space Telescope and future Earth-based interferometers, we may soon capture direct images, pictures of actual worlds orbiting the stars of Alpha Centauri. Worlds that may have blue skies, clouds, continents, maybe even life, for light years. In cosmic terms, it's next door, but in human terms, it's vast. With current rocket technology, a probe would take tens of thousands of years to reach Alpha Centauri. It is a distance that daunts even our boldest missions. And yet, a project known as Breakthrough Starshot aims to change that. Backed by physicists and billionaires alike, the idea is to launch tiny interstellar probes, just grams in mass, powered by light sails and accelerated to a fraction of the speed of light using high-powered lasers from Earth. These chips would carry cameras, sensors, and transmitters. In just over 20 years, they could reach the Alpha Centauri system and begin beaming back data. Images of Proxima b, spectra of alien atmospheres, shadows of other worlds. It would be humanity's first visit to another solar system. A journey not of astronauts, but of information. For centuries, we've looked to the stars and asked the same question: are we alone? The discovery of exoplanets has changed how we ask it. We now know that planets are not rare, they are everywhere. Nearly every star in the night sky may host them. But Alpha Centauri is more than a dot in the sky. It is our next-door neighbor. If life exists there, even in microbial form, it would suggest that the universe is not only full of planets, but full of life. And if we find nothing, that, too, tells us something profound. That life may be rarer than we imagined, and more precious than we ever knew. Either answer reshapes our understanding of ourselves. In Alpha Centauri's hidden worlds, we glimpse not just alien possibilities, but reflections of our own origins, and perhaps our destiny. There is a time in every journey when we stop walking and start wondering. Alpha Centauri represents that moment. It is not unreachable. It is not a fantasy. It is a destination waiting to be explored, one star system away, glowing quietly beyond the reach of our eyes. Its planets, still hidden, may be rocky, oceanic, airless, alive. We do not know, but we are closer to finding out than ever before. The next chapter of discovery begins not in our backyard, but in our neighbors, across the void, across time. And when we finally see those hidden worlds with our own eyes, whether by telescope, probe, or imagination, we will be seeing more than just alien landscapes. we'll be seeing the edge of possibility. Because the search for life in Alpha Centauri is ultimately a search for ourselves.